Hello everyone. This video is term assignment 2 of course Metrology and Quality Control, course code 2ME 401. The topic for this video is alignment test of lathe machine. So let's begin with what is lathe machine. A lathe is a machine tool that rotates a workpiece about an axis of rotation to perform various operations such as cutting, sanding, knurling, deformation, drilling, facing, and turning, with tools that are applied to the workpiece to create an object with symmetry about that axis. A lathe machine chips off excess materials and shapes the job according to our requirements. Now we see what is alignment. Alignment is an arrangement in a straight line, be it vertical axis or horizontal axis, in a correct relative position. So what is the need of alignment? Before the various operations on any machine tool are carried out, it is very essential that it should be installed in truly horizontal and vertical planes. In horizontal plane, both longitudinal and transverse directions are equally important, otherwise it may undergo severe bending or twisting. Now I'll just brief you about the parts of a lathe machine. First is headstock, then we have tailstock, bed, carriage, lead screw, feed rod, chip pan, and hand wheel. Moving on, now we will discuss a few tests we perform on alignment of lathe machine. First we have is leveling of a lathe machine. Firstly, the machine chassis should be installed on a truly horizontal and vertical plane. If the lathe bed is quite long and therefore not installed horizontally, the bed will undergo deflection, thereby producing a simple bend, and undesirable stresses are produced which can eventually harm the lathe. Also, due to inappropriate placing of the bed, unwanted twists can also be introduced in the lathe. And due to this twist, the movement of the saddle cannot be in a straight line and a true geometrical cylinder cannot be generated. Another point which falls under leveling of the lathe machine is that a concrete foundation needs to be prepared of considerable depth for proper installation and accuracy maintenance, because accuracy plays a major role when we are preparing a job on a lathe. Now moving on to the sensitive spirit level, which is the instrument used for measuring the leveling of a lathe at various parts. I will brief the following points which fall under this instrument. A sensitive spirit level is generally used for testing longitudinal and transverse directions of a machine bed. What we need to keep in mind is saddle is kept at the center of the bed support feet. Spirit level is then placed on the bed. The level readings are noted along the longitudinal as well as transverse directions. For the transverse direction, the sensitive spirit level is placed on a bridge piece to span the front and the rear guideways. We need to keep in mind that readings in transverse directions denote twist or the wind in the bed. Another main point is that longitudinal readings might be perfect, but the guideways should be parallel to each other. The permissible error or the maximum permitted error in the lathe is 0.02 mm per 1000 mm. Now moving on to the next test we discuss, my friend Vatsal will continue from here and explain the other few tests conducted on a lathe before performing operations. Thank you.
So our next point for alignment test in lathe is parallelism of the main spindle to saddle movement. It needs to be checked in both vertical and horizontal planes. Mandrel is to be used in the test, and if axis of the spindle surface is not parallel to bed in horizontal direction, a tapered surface is produced. Hyperboloid surface is produced due to deviation between spindle axis and the bed in vertical axis. So now we come up on the mandrel. Mandrel to be fitted in the tapered socket of the spindle. It has concentric taper shank which is closed fit to the spindle nose and taper. The filler of the dial indicator is pressed on the mandrel and the carriage is moved. The indication of the horizontal plane is given by dial B and the vertical plane by dial A. So another important thing is true running of locating cylinder of main spindle. Locating cylinder is provided to locate the chuck or faceplate. The dial indicator is fixed to the carriage on the lathe and the filler of the indicator touches the locating surface. The surface is then rotated on its axis and indicator should not show any movement of needle. So its permissible error is 0.01 mm. So next is true running of headstock center. Headstock center is live center which has spindle on it and the chock to hold the workpiece, and the workpiece is rotated with its center. If it is not true with the axis of movement of the spindle, eccentricity will be caused while turning a work. For testing error, the filler of the dial indicator is pressed perpendicular to the taper surface of the center and the spindle is rotated. The deviation indicated by the dial gauge gives trueness of the center. So its permissible error is 0.01 mm. So in this figure you can see that the work is taking place on the workpiece. Another is true running of taper socket in main spindle. If the axis of tapered hole of the socket is not concentric with the main spindle axis, eccentric and tapered jobs will be produced. To test it, a mandrel is fitted into the tapered hole and readings at two extremes of the mandrel are taken by a means of dial indicator. So its permissible error is 0.01 mm. Up next is movement of upper slide parallel with main spindle in vertical plane. A dial indicator is fixed in the tool post. A mandrel is fitted in the spindle. The filler of the dial gauge is presented against the mandrel in vertical plane and upper slide is moved longitudinally. This error is not tested in horizontal plane because there is failing arrangement for taper turning. So it's permissible up to 0.03 mm per 150 mm. So up next is alignment of both the centers in vertical plane. Besides testing the parallelism of the axis individually, it is necessary to check the relative position of the axis also. Both the axes may be parallel to carriage movement, but they may not be coinciding. So when a job is fitted between the centers, the axis of the job will not be parallel to the carriage movement. This test is to be carried out in vertical plane only. A mandrel is to be fitted between the two centers and the dial gauge on the carriage. The feeder of the dial gauge is pressed against the mandrel in vertical plane and carriage is moved and the error is noted down. Its permissible error is 0.02 mm to 300 mm.
Thank you so much everyone for watching the video. This video is performed by Maharsh 18BME 059 and Vatsal 18BME 025 under the guidelines of Mr. Hiren Prajapati. Thank you for watching.